Welcome back, guys. So this is question 2.21 of our book Electric Circuits by Nilsson, and the statement of this question is the current IA in the circuit shown in figure P2.21, this is the figure P2.21, is 2 milliamps. Okay, this is the IA and the value of IA is 2 milliamps. Okay, so on the basis of it, we have to find what? We have to find the value of I naught. This is I naught. The value of IG. This is IG. And see the power delivered by the independent current source. This is the current source. We have to find the power delivered by this one. Okay. So let us start it. And in starting it, we have to find different quantities. And let me solve it here. So solution of it. Okay, so first let me have here the KCL. So according to the current Kirchhoff's current law, here this current is flowing towards this node, which is here, and let me call it node A, and here the current which is flowing towards it is IG. Okay, and then it divides into two currents. The first one here is I naught and the second one here is IA. So according to the KCL, IG is equal to what? That is equal to I naught plus IA. Okay, here we just know the value of I of A. Okay, this current is known, and this is the similar current which has been flowing through all these three resistors, because these three resistors are in series. When these three resistors are in series, we have to find the equivalent resistance of that, and that would be the 1 kilo ohm resistor plus 4 kilo ohm resistor and plus 3 kilo ohm resistor. So ultimately we will get the 8 kilo ohm resistance. Okay, so this is the equivalent resistance here, and here if we can see the equivalent of it, we can see that here these two resistances, where this is the equivalent resistance, this is the 2 kilo ohm resistance, and here we have this current source. These three are in what? These three are in parallel with each other. This is the I of G, and from it this current is flowing. This is here, this one is here, and this is here. Okay, so let me have here, this is A, and let me call the voltage across it as VA. So this is the same voltage which is here and here as well. Okay, so this is the same voltage. If we can find out the value of this VA, which is here and here as well, we can find out the value of current here as well. Okay, so let me first find the value of VA, and the value of VA is what? That is this IA, which is flowing through all of these resistances. So IA multiplied by this equivalent resistance which is here, because this is I of A. Let me put these values here. The value of I is given, and that is 2 milliamps. Okay, so that is 2 into 10 to the power minus 3, and the equivalent resistance here is 8 kilo ohm. So that is 8 into 10 to the power 3. These two will cancel out, and ultimately here we will get what? The voltage here is 16 volts, and that is V of A. So let me take this one here. If this voltage is known, this is known, this is known, and this is also known, so from it we can very easily find out the value of this current, which is I naught. Okay, why? Because with each of the passive element we have three quantities associated, which are voltage, current, and resistance. If two of them are known, we can easily find out the third one. So here this resistance is known, the voltage is known, we can very easily find out the value of I naught. So using the Ohm's law, okay, the value of I naught is what? That is the value of VA divided by the resistance, that is 2 kilo ohm. Okay, so let me put these values here. So this is 16 divided by 2 kilo. So ultimately the answer of it is 8 milliamps. Okay, so the value of I naught is known, and that is 8 milliamps. Okay, so I naught is already known. So from this formula, if the value of I naught is known, the value of I is already known, so we can very easily find out the value of Ig. So the value of Ig is what? I naught is 8 milliamps, Ia is 2 milliamps, so that is 10 milliamps. Okay, so that is what? That is basically the solution of part B. Okay, so this is part B, this is part A. Okay, now we want to find out the power delivered by this source. Okay, so now for the sources, we know that, let me solve it here. For the sources, we know that the power which is generated or dissipated is equal to V is equal to V multiplied by I, where V is the voltage across the source and I is the current provided by it. So the voltage which is here is already VA, because all of these three are in parallel, and the current is IG. Okay, so let me put all these values. So it will be 16 multiplied by this 10, okay, into 10 power minus 3, because this is the milliamps, so it will be 160 milliwatts, and that is what? That is the solution of part C of my question. Okay, so that's it for today, in which we have seen that by employing the concepts of the series circuits, by using the KCL, by using the Ohm's law, and then applying the concept of the power generated or dissipated by the voltage or current source, we have solved this question. If you have any question, you can ask me in the comment box. See you soon.